All right, hi everybody. I'm Mike Meredith. I'm from Victor Ops out of Boulder, who you just heard of. I wanted to thank Puppet Labs for putting this event together and for inviting me to speak. This is the second Puppet camp that I've been to, and I think these are just fantastic events, really immersive. So I really appreciate them putting it on, and to Code, of course, for hosting this here. I'm going to be talking about how to manage your Nagios server with Puppet. It's kind of a nice kind of general introduction to kind of deeper aspects of managing a particular application with Puppet. So I think it's valuable. By show of hands, how many people here are actually using Nagios to monitor their environments? So a pretty good number of you, and that's not too surprising. At Victor Ops, Nagios is definitely our most used integration, so not surprised to see lots of you using it. And if you're not using it, don't worry. A lot of the concepts that I'm going to be talking about here can be applied to managing other software as well. So first, let me touch on why you might want to do this. There's a few good reasons. First, it helps avoid monitoring gaps by adding new hosts and services as soon as they're provisioned. I don't know how many times over the course of my career, I've built a host, I've rolled it out, I've managed the applications, I've got it up and running in production, and then 3 weeks later when the thing goes down, I realized I never added the thing to the Nagios config. Managing it in Puppet, at least the way that I'm going to demonstrate it here, eliminates that issue for you. It keeps your Nagios config stylistically and syntactically consistent, and that keeps it easy for humans to read and understand the configuration when they need to. Kind of ironically, computers are much better at writing readable configurations than humans are, at least sometimes. And lastly, it's a cool way to learn about several kind of key Puppet features. Puppet has built-in support for generating Nagios configs, which makes this example really quite easy, but the principles involved here can be used to manage other applications, and we'll lightly brush against, like HA proxy management, for example, during the demo, so you can kind of see what I mean. All right, so let's talk about these key Puppet features I keep alluding to, and that's exported resources, that's Hira, that's inline templates, Factor, the Nagios resource types, and the Puppet filters. Not all of these are necessary for managing your Nagios config, but they all solve at least one particular problem for me, and they're all worth knowing about. So I'll give a very brief introduction to each feature here, because I know that a lot of people in the audience today are fairly new to Puppet. And as with the other speakers, if you have any questions as I'm going through things, don't be afraid to throw up your hand and ask. All right, so exported resources is a big one, and it's kind of the key secret sauce for my solution here. And the idea is that you have a resource that gets defined by one host, but implemented by another. And exported resources make use of the Puppet DB, which means this solution doesn't work great in a masterless environment. You can run a Puppet DB in a masterless environment, but then at that point you've created a central dependency, so you might as well run a Puppet master and get the benefits that go along with that. In the example on the screen that you see here, the node running the policy is going to define a Nagios host resource, and we'll get into what that is exactly in just a little bit, and applying a bunch of locally sourced variables to that resource. So it's creating the Nagios config entry for itself. But the resource has been called with the two @ symbols right there at the resource type, see? And that means that instead of trying to render the resource in the config file itself, when the host renders the resource, it's going to store it in the Puppet DB and tag it as an exported resource. The next time the Nagios server does a Puppet run, it's going to query the Puppet DB and find out if there are any exported Nagios resources for it to implement, and then do the actual creating of the configuration files. And that part's called collection. Now, this is an extremely powerful feature that has a lot of applications. In the demo, you'll see an example of HA proxy management using exported resources as well, using a Puppet Labs module. So that's a pretty cool way of using it as well. There are other ways of managing Nagios configs. There are some implementations for Puppet management of Nagios that have each host render its own configuration files and place them in an NFS directory or transfer them to the Nagios server in some other way. I don't like this, primarily because it creates a forest of little one resource configuration files, and that makes the configuration hard to navigate. The beauty of exported resources is that the Nagios server will collect all of the Nagios resources and put them in a single config file without having to monkey around with any kind of shared storage. All right, next on the feature list is Hira, and we've had a little bit of an introduction to that earlier this morning, so that's good. Very briefly, it's a way of separating your code from your data, just to review. It means a couple of things. It means your code is more reusable because you're not defining site-specific variables in the code itself. You make references to variables that are stored in Hira, and the Hira lookup handles site and environment-specific overrides. Second, it's a way of keeping more sensitive data slightly more secure, since Hira can use encrypted backends. So you can store database passwords and other sensitive information in an encrypted store, and then even if your source code gets stolen, your public policy, that information won't necessarily leak out. Of course, the puppet master, or whatever machine is applying the puppet policy, needs to have the key on hand to decrypt the encrypted store. So it's really only a security benefit if you're using a puppet master server that's fairly well hardened. Using encrypted Hira wouldn't make a ton of sense in a masterless environment, but that kind of underscores the overall security disadvantage of a masterless setup, where you would have to have all of your policy, all of your decryption keys out on every host. On the right, over here, hopefully you can see a portion of a Hira database using the default YAML backend. As you can see, you can define variables, you can define arrays, you can define hashes, and it's hierarchical, meaning that you can define default values for things and then set environment-specific or location-specific or even host-specific overrides according to a hierarchy that you define. And we'll kind of get into the specific example of that in just a little bit. All right, inline templates. The Puppet DSL is, of course, very powerful. And it's well adapted for use as a declarative configurable language, which of course is what it is. But there are some more complex ways of handling data that aren't available in the Puppet DSL. At the bottom of the slide, some of you hopefully can see an example from my demo. And what I'm doing here is I'm building an array of the defined variables that match a regular expression. And that's a function that, at least as far as I know, isn't available in native Puppet code. But since inline templates use the Ruby ERB format, just like regular templates in Puppet, an inline template is kind of a sneaky way of calling native Ruby functions within your Puppet policy, and that can be useful for this kind of string and array handling. Inline templates are also a good way of creating files, of course, if there's not much going into the file and it won't muck up your policy too much, or if the file content gets defined in Hira or something like that. Okay, factor, hopefully we all know about factor. This is of course where we get a lot of our locally defined variables, and those can be extremely helpful when you're building a Nagios configuration. One thing to note about factor is that it's easy to create new facts and add libraries for defining them to your Puppet modules. So really anything that you can determine from the command line or from proc or whatever, you can turn into a fact with Puppet. And Nagios resource types, and this is where Puppet really makes things embarrassingly easy by providing native resource types for Nagios configuration objects, meaning hosts and services and host groups and so on. Other applications achieve this by creating defined types in modules, but for Nagios, it's not necessary. It's built into core Puppet. This is great because while Nagios configuration is well enough understood, as you know, at least as those of you with experience with Nagios know, it's tedious and kind of intricate enough that it's easy to make a minor mistake that'll cause the config parse to barf when you're building it by hand. Of course, Nagios has several derivatives like isinga1, like Niemann, like Shinken, that can all use Nagios configurations. The code in my demo can be adapted to manage any of them with a bit of work. The demo called also installs Nagios 3, I'll mention, since Nagios 4 is not yet available in package form on most Linux distributions. But when such packages do become available, this should work just fine with Nagios 4. Nagios 4 is a big major rewrite, but managing it is pretty much identical to managing a Nagios 3 instance. Now, I'm not recommending that you use nothing but Puppet Nagios config object resources to go from 0 to a full config. There are aspects of Nagios configuration, like contacts, or like integration with external tools like VictorOps, that should be managed at the file level rather than the config object level, and that's fine. Again, what this is doing for us is helping us make the configuration dynamic to take account when hosts are commissioned and decommissioned. And naturally, my demo is going to be using a fair number of modules from the Puppet Forge. And I really want to commend Puppet Labs for making the Puppet Forge more useful recently by publishing the quality score and the community rating numbers for published modules. You can see an example here. It's not foolproof, but it does help identify the modules that are best trusted and maintained by the community. Puppet Labs also marks some third-party modules now as Puppet approved, so that gives a bit of extra confidence that you're going to be using something safe. Browsing through the approved module list is also kind of a nice way to kind of get ideas for new ways to manage your infrastructure with Puppet. You might see something in there, hey, I'm using this application, and somebody's already written a module to manage it. It's Puppet approved. That's great. Somebody's already done a lot of your work for you. Good stuff. I definitely do still advise you to review and understand any Puppet Forge module before you install it. Puppet is most likely running with a root level access on your systems, so the potential for damage is very high if a module does something you don't want or weren't expecting. All right, now there are several third-party modules in the Puppet Forge for managing Nagios, but none of them suited my particular use case, so I decided to build one from scratch. I wanted the module to automatically add new hosts when they get provisioned. I wanted some service check definitions to be defined with the services themselves. I wanted to automatically remove decommissioned hosts, and I wanted to make use of host and service groups. And I just didn't find anything in the Forge that kind of did all of those things for me. And I guess I'll note that the kind of demo that I'm going to show you, the approach that I'm taking here, is great. If you kind of meet a kind of short list of requirements, if you like. It works great if you're giving your hosts functional host names, like if you're naming your web servers things like Web 1 and Web 2 instead of things like Elmo and Grover or something like that. And it works great if you have a fairly dynamic environment where you might be adding maybe 5 or 10 hosts a week or taking away 5 or 10 hosts a week. But it's not going to be super great for like a super elastic environment where you've got hundreds or thousands of nodes that are appearing and disappearing on a daily basis. This really isn't designed for that. Okay, so to put the pieces together, hierarchy factor come into play first, of course, defining variables for our monitored hosts that they'll need to export their resources. Again, we're making use of Hiera to provide same defaults for most variables and allow for environment and location-specific overrides. Monitored hosts figure out for themselves what host groups they belong to. They assemble their config objects for export. And they build their NRPE config for the locally running NRPE daemon. And that's how Nagios does remote checks of like file system utilization and other local services and monitored hosts, if you're not familiar with it. As you'll see, I've created exported resources for some services, notably Apache or also HA Proxy, with the idea that if you call the class to be an Apache server, then you'll need to monitor Apache. And if the configuration for Apache changes, then the way you monitor Apache might need to change as well. So you put that service definition in the same place where you're managing the service itself, and that makes it a little easier to manage, easier to remember, that you need to update your monitoring config if you're updating the config. Of course, all this fancy footwork has a cost in catalog compilation time and processor load on the puppet master. And some services get monitored the same way on every host, within a given host group at least. Things like swap, things like your root file system utilization, stuff like that. And for those services, it might make more sense just to have a static config file that doesn't have to update all the time. Debugging problems with exported resources can also be a bit of a challenge. So if there isn't a compelling reason to export a resource, it's worth considering whether to manage that resource in some other way. And here's another slightly tricky bit. A lot of Puppet resource types have a notion of purging unmanaged resource. The user resource type is an example, where you can basically get Puppet to automatically purge any user on the system that isn't explicitly defined by your Puppet policy. And that's kind of handy, for making users automatically go away just by deleting them from your policy. Unfortunately, the Nagios config object resource types don't include this functionality. Now, it would be easy enough to just rebuild the Nagios config from scratch and send it a restart at everyone, but Nagios doesn't like to restart that often. If you have a lot of checks running, it can really kind of screw up your check schedule. So I wanted to try and avoid that. So rather than build the Nagios configs in place, my module builds them in a temp directory, compares that to the running config, and only if there's a diff, it will move the configs into place and restart Nagios. The temp directory gets cleared out at every run, so the files will get rebuilt without any host or services that have been decommissioned since the last build. It's not super clean, and it causes a bit of extra work for Puppet on the Nagios server, since it has to render the files at every one, whether there's a change or not. But it does keep the config up to date, and it does prevent restarting Nagios all the time. Plus, I can save off the previous revision of the config and quickly restore it manually if something goes haywire with the Puppet policy. A quick note on the demo environment. I'm using Vagrant for the demo here. And if you don't know about Vagrant, you need to know about Vagrant. How many people use Vagrant here? Just about everybody. And it's, awesome way to work on Puppet code because it allows you to quickly build up and tear down little virtual environments and test policy without mucking up real servers. My Vagrant environment here has 7 VMs running various functions to facilitate the demo all on my laptop. It's super easy to set up. You can see the link down here at the bottom. I'll put up the link again at the end of the talk. But I note that this demo environment is on GitHub. You can download it and run it for yourself if you like. It contains all the Puppet policy, and there's a README describing how to get the environment up and running. And you're more than welcome to use my Nagios module or anything else you've seen in the repo. Okay, so let's switch gears and we'll see some of these principles in action. All right. So here's our Nagios dashboard. As you can see, I'm monitoring several hosts, 6 hosts total, HA proxy server, MySQL server, a couple of them, the Nagios server itself, our Puppet master, and then a web server. And that's great. Everybody's got all their services running, and it's doing well. As you can see, I've also got my HA proxy server here. It's only got one web backend in it, but it's happy, everything's doing fine. Now let's say that I decide, I need another web server. I'm running out of capacity for my web servers. So what we'll do here is I'll bring up a second web server. As soon as it's done booting, the first thing it's going to do is it's going to do a run of its Puppet policy. It's going to figure out that it's a Nagios client. It's going to make sure that it's got NRPE installed and all the right checks installed. and then it's going to export its host and service definitions to PuppetDB. Just to make extra sure, I'll do that. And it's exporting resources for Nagios. So the next time I run my Puppet agent on the Nagios server, it's rendering the config for all the files. Because it noticed that there was a difference in the files between the ones it just rendered and the ones that were running, it put those into place and it bumps the Nagios configuration. And if I go back to Chrome here and hit reload, I can see that now I've got my Web 2 server and all of its services provisioning, and it's getting ready to start monitoring. Like I said, I also export resources for the HA proxy server. So I run Puppet agent on HA proxy. It says, hey, I've got a new web server for our backend. It adds that to our HA proxy config. If we go over here, we can see now we've got 2 web servers. And going the other way. So now let's say I decide that I've got too many web servers for whatever reason. So I will do a vagrant halt on Web 1. Now obviously you don't want this to immediately disappear from your Nagios configuration, because if the host is legitimately down, you want to be notified about that. But if you say, okay, this is a decision that I've made intentionally, I want Web 1 to be down, so I don't want to be notified about it, and I want Nagios to stop monitoring it, I'll go to my Puppet master here, and I'll deactivate the node. Puppet node deactivate. And this doesn't clean out the authentication key, the SSL key, or anything like that, but it basically just marks that node as inactive in the PuppetDB. So other hosts that are collecting exported resources will know that they should ignore resources exported by this host. So that happens. We go back to Nagios, we do a Puppet run. We go back to HA proxy, we do a Puppet run. Again, we see that the config changed, so it restarted Nagios for us. And if we go over here, we'll see that the Web 1 server has been deprovisioned from our Nagios configuration. HA proxy is reporting an error right now, but if we reschedule a check of that, it's going to recover, because HA proxy now only expects a single host to be involved. And that's reflected in HA proxy as well. Web 2 is the only host left in there. So that's kind of the principles at work. And now let's have a quick look at some of the code that's making all of this happen. All right, to cover Hira real briefly, you can see this is a Hira.yaml file, and this file lives on the Puppet master, and it defines the configuration for your Hira database. We're using a single backend, that's the YAML backend. It's saying for the environment that your Puppet policy is running for, that's where you're going to look for your Hira data in the form of YAML files. And then this defines the hierarchy. So it's going to look for a file called defaults.yaml, which you can see over here. And if there's a location-specific file that contains the variable, that's going to override what it finds in defaults. If there's an environment-specific file that contains a variable, it will override location or defaults. All the way up to if we have a file that's defined for an FQDN, that's the top of the hierarchy. So anything that gets defined in there is going to override those values that you see everywhere else. So as an example of that, vagrant is our location for our purposes of this demo. You can see that we define a lot of variables in here, including variables that get called in classes, as well as class parameters. Those can also get defined in hierarchy. But on Nagios 1, so in our defaults, we're calling some class defaults for our Puppet class, which sets up the Puppet client on all of our client machines. And we're setting a run interval of 600 seconds or 10 minutes. Way too fast, by the way, for a natural production environment. But for our Nagios server, I wanted that to run more often, so I created a node-specific YAML file and did overrides for those same two variables, setting those to 300 seconds. So when the policy runs on the Nagios server, that variable is going to get overridden that way. All right. So this is kind of interesting to look at as a contrast to kind of the external node classification that we've seen earlier today. I don't use an external node classifier in my demo. Instead, in my site PP, I just do some parsing on some factor variables like the FQDN and the domain, and taking elements out of that, I do regex matches, and then set variables for whether this is the dev or the stage or the lab environment, or whether this is the, let's say, the vagrant or the KCMO or the SPMN location. So I kind of prefer to do things that way because your node classification, all of your logic basically for your Puppet policy is here in the GitHub repository, is here in your Puppet code, and you're not kind of managing your Puppet configuration in two different places. But different things work for different people, and that's one of the great things about Puppet is that there's 5 different ways of doing anything that you care to do. We also set what server type things are by parsing out the host name. And again, this is why this approach works better if you've got functional host names for all of your hosts and you're real consistent with that naming convention. If you're naming your hosts after Lord of the Rings characters, this becomes difficult and unmanageable, and is not a great approach. All right. So I create a common module. Basically, every node runs that. And this is similar in many ways to the kind of Puppet Labs roles and profiles approach. And they would probably call this a role module instead of a common module. And I may actually make that change in here at some point. But I'm exporting those top-level variables from site.pp, and then depending on what kind of server you are, and whether or not you're in a vagrant bootstrap mode, or whether you're kind of fully up and running in a regular mode, I figure out what classes I need to call, and perhaps some of the parameters that I'll call with them. For example, everybody calls the class Puppet, which by default installs you a Puppet agent and configures the agent to talk to the Puppet master and all that good stuff. But on the Nagios server, I add a class parameter of a pre-run command. Really hard to see, I know. That clears out that temporary directory where I build my Nagios configs. And that's a handy way. This is, by the way, a dangerous pre-run command. I added the star.config there because when I was first setting this up, I I badly defined that variable. So the first time I ran it, it set up my Puppet config and said that the pre-run command was rn-f/star. Rookie mistake. Okay. And let's look at our HA proxy server where I'm calling a profile module VOHA proxy. And here I'm calling the Puppet Labs HA proxy module class with a bunch of options plugged in. But here you can also see an example of exported resource collection. Our web servers export HA proxy balancer member resources. Let's say, okay, this is the listening service that I'm subscribed to. Here's my FQDN, here's my IP address, here's the port, here's the options. So when that host comes up and exports that resource, and the next time the HA proxy server runs, this little double bracket pipe says, look for this tag, listening service equals, and then it's using a hierarchy lookup to find the value for that. And then implement any HA proxy balancer member resources that you see exported in the Puppet DB that match that lookup. And that's how it automatically adds hosts to the HA proxy config when they add in. And you can see that it's also, in the same vein, exporting a Nagios service for itself for HA proxy. And it's telling it to check NRPE, and which host to check it on, which is of course itself. And then in its own turn, the Nagios server, when it does its run, is going to collect that resource. And to kind of dive into the Nagios module that I've created itself, if you look at the regular initpp, it doesn't actually do anything much by itself. It installs some supporting packages, plugins that we want installed everywhere, whether or not it's running as a Nagios server, because those plugins can get called by NRPE to do local checks. And then a little directory that we set up for adding in-house plugins that we'll set up. But when you get called for the VO Nagios module, you either get called as a server or as a target. So if you get called as a target, you set a bunch of variables, you export your Nagios host configuration, you include that base VO Nagios class that installs the supporting packages, and then you do this. This is kind of one of the more complicated pieces of it, to figure out your host groups. And here's where I'm using inline templates and so on, because there's all kinds of facts that it's pulling in and saying, if this is true about me, then I'm part of this host group. And if this is true about my FQDN, for example, then I belong to this host group, and so on and so on. Figures all that stuff out, joins it into a long array, and then adds that to the host definition as well. The server, for its part, gets called here. It installs all of the server packages. That's not really very complicated. It manages the Nagios service. Again, that's not very complicated. But it does the config management as well. And here's where a lot of that happens. Up here at the top, you can see a lot of fairly static stuff that gets managed. We set our Nagios admin password from higher up. We set our web access passwords using a fairly static config. And then we've got things like commands config, resource config, and a few other fairly static config files that we're just going to copy off the master and not worry about generating dynamically. And then it's going to start going through all of these classes here, which are our dynamic config. And in each case, it's basically going through and saying, okay, if I'm in the PR environment, I want to collect any Nagios host that's a generic host, or any Nagios host that's a PR host. Assemble those all in one host config file, and then that's my host config. And the same thing kind of basically for services, PR services, staging services, dev services, so on and so on. Your Nagios configuration, or your server in each environment is grabbing the exported resources that are relevant to its environment that it's going to be able to monitor. And then we do our config install step here, where we basically create all the files, and then we diff those against what's actually in the running config. And if there's a difference, then we copy those files into place, and we notify our Nagios 3 service. One thing to note is that we're defining something called install Nagios config, so that we can control kind of the order that all of this stuff gets executed in here. And then calling that here with an array of basically the list of our dynamically generated config files. So that's a kind of a way of doing iteration over an array today. This is an example of using a defined type to create sort of function type functionality within your Puppet code. So hopefully that makes a little bit of sense to everybody, and you got something out of that. Again, the demo environment is on GitHub. I definitely encourage everybody that's interested to download it, check it out. If you care to contribute to it, there's a lot of work that can be done in that module, and I would love to kind of develop it to the point where it's a Puppet Forge worthy module, and that means kind of adding some parameterization to the class, maybe managing more types of config resources, adding some cross-platform support. Right now it's only kind of tested to work on Debian-based releases, and some more documentation for the module. If anybody's interested in hopping in and contributing to that, that's awesome. Or if you just want to download the code and fork it and use it for yourself, that's absolutely cool too. And at this point, I would love to answer any questions anybody has. Yeah?
Have you found any other methods of defining host types other than host name?
So the question is, are there ways of defining host types other than the host name? It kind of, in Puppet policy, it sort of becomes a chicken and egg problem, right? Because you could say, well, I could define my host type based on what's running on the host, but of course what's running on the host has to be defined by your Puppet policy, which needs to know what host type you are before it can manage that. But you know, there's other things that you kind of know are consistent, you know, and it could really be anything, right? Like if this file system is mounted, then I know I'm X type of host, and you know, you could do it that way, or based on any other kind of system level metric you find. Certainly I do certain policies on the basis of, are you a virtual machine or are you a physical machine? So I can do some differentiation in that way. But at least kind of my personal philosophy is that your life in general is going to be a lot easier if your host names mean things. Any other questions? Yeah, the question is, are the Nagios resource types available in the open source version? And the answer is yes, they're all available in Puppet Open Source and Puppet Enterprise. I have wondered, because they're a little bit of a strange thing. They're the only kind of built-in Puppet resource types that are this application specific. And so I've kind of wondered to myself over the years if Puppet Labs is going to kind of take these out of the core product and kind of modularize them at some point. And it wouldn't surprise me if they did. I don't know, somebody from Public Labs can probably speak to that better than I can. But I know that if they did, enough people are using the functionality that I would probably just take the form of a Forge module and manage it. What's that? That's what's happening. There we go. I don't know what shape that's going to take, but I think that the kind of way you manage these things wouldn't be much different. You would just have an additional module to install.
Unfortunately, that was the last question. Feel free to find Michael during lunch. Sorry, and pick his brain. Thanks, Michael.